Hello all. Today I'll be talking about SigNoz, which is an open source APM and observability tool. It helps developers and DevOps team monitor their application performance and troubleshoot their problems. It is an open source alternative to tools like Datadog, Neurotic, etc. SigNoz uses distributed tracing to gain the visibility into your software stack, and I will briefly tell you about how SigNoz works and what APM and all pretty much in brief later in the video. So again, APM, which is application performance monitoring, refers to the monitoring of performance and availability of an application. So it's a practice of keeping track of key application performance metrics using monitoring tools and telemetry data. Telemetry data. So we will go through a better understanding of what APM is later in this video. So now before diving into what APM is, right, let's first understand why do we need it. So in today's application environment, are highly distributed cloud native ecosystem, and that are in constant flux as they change, expand, and scale. Each request or transaction move from server to server, and the request may also branch out into multiple threads, right? So if a performance issue arises in any of this large ecosystem, hardware, network, code, or backend, any could be a culprit. And without an APM tool, we have a very limited performance monitoring options, and this limited visibility makes it harder to identify the root cause of an application performance issue, right? And resulting in a long downtime. The only and again the current this limited options only provide you a single view of an application architecture, right? And which often misses the part where the cause and effect of a performance problem is not fully considered, right? So for example, increased CPU usage is caused by multiple microservices failure, right? I know it's a bit of very theoretical, but I'll make you understand it better and in the next couple of slides, right? So to understand it better, let's take an example of a microservice based architecture app like this. This is an application where we have three services running inside Kubernetes cluster. Node service to handle third-party API calls, operations, and Java a service to perform CRUD operation on DB, Python for data processing or ingestion, and then store whatever processed file there in the AWS S3. Just a very basic example. I'm just giving you one way of a communication just to keep understanding very simple level, right? So as you can see, Node communicates with Python and Java service, and Python communicates with Java. So the client request is routed through the API gateway that communicates with the respective service depending on the request type. Now, consider a scenario. Let's take in front end performance, right? If that is also one service, the options to gain a fully visibility on how users are experiencing the application are very limited. I mean, definitely you can run a test on transaction from time to time, but it is kind of reactive, or you can wait for user to complain and then act on that. So in another scenario where request comes from client, right, and it is unable to reach to a desired service. So let's say in this case the request comes from a client and goes to a node service, but node service is not available, like it's giving you 500 HTTP error code, right? And we are not sure what is happening. This is one way to just imagine the scenario. And let's say in another example with the same architecture, let's say you do a new release of a node service, right? You update a node service package to version upgrade to 1.2.0, right? And it's live. But the moment it goes live, after some point of time, you realize that there's a bug in the service, and which is nothing but instead of doing a single update request from node to Java service, which is supposed to do CRUD operations on DB, now node service is sending bulk updates, right? And bulk updates to basically Java service, which further delays the response time by increasing the load on database write operations and eventually failing the service, correct? And if you consider it in another way, if you will not be able to, I mean, the Java service, eventually the response will not get back to client, right? Because nothing is getting updated on DB because the Java service is completely flooded. And then another example could be like, let's say you have done changes in node service, right? But your Java service is not, Java service or the code that you have written is not compatible with taking a bulk update. So again, it's a downtime for your service. And considering the same scenario, let's say in a few moments you get a new request from API gateway to directly communicate with the Java service, and you are not able to get a response because Java service is already flooded and it's down, right? So okay, sorry. So so basically in both the cases or whatever scenarios we have explained, what could be the issue? I mean, I have explained right now, like as I'm explaining now, you know it, but when you consider your application, you do not have any understanding of what exactly going on, and whether why node service is not responding, why Java service is not responding, why I'm not getting a response on a client side after calling third-party APIs or whatever it is, right? So is the API gateway down or the node service down, or it could be entire cluster, right? How do you know that? So without an APM, like currently the logs, traces, and collection of individual services is very tedious, like because of distributed nature of the application, right? And you don't have a code level data to discover the criticality and isolate the code related problems, right? I mean, you can still collect the logs of different services like this. I mean, you are collecting logs on network level, database level, service level, and since it's on Kubernetes cluster, it's right now it's kind of easy to collect all the service logs, right? But then how do you see it, like, hey, this is the main problem is, right? You could collect the logs, you could code relate it, but then again it's a tedious job because this is one example, but in applications where it's highly distributed or you have like 100 of services, right, it's quite difficult to correlate and manage all those logs at time. So without an APM tool, that's a problem. And another thing is your application stack and infrastructure is completely black box, right? Because there is no way no way to tell where request transaction failed or slow transactions spend their time on which servers, which method, or which backend. It's hard to find the root cause of a problem. And if you are not able to find a problem, then it becomes a blame game between the teams, right? Everyone pointing fingers on each other, whether it's a DB issue or infra issue or the developer team, right? Just like this, or maybe like this. So that's a problem. Now we have understood what is the need of and why do we need APM tool. Now let's better understand what exactly is APM or what is an APM tool, right? So just to give you another definition on top of whatever we learned right now, APM is used to ensure system availability, optimize service performance, response times, and improve user experience. That's the goal of overall APM tool in general, right? And APM tools aim to detect and pinpoint application performance issues before real users are impacted. And a robust APM tool helps the DevOps team to keep tabs of different application and system metrics as well, such as resource consumptions, resource time, error rates, to ensure that the application is basically performing in the desired manner with the expected performance, right? And by monitoring performance metrics over a long period of time, the process of evaluating an acceptable performance expectation for application becomes much easier and more straightforward for DevOps folks, right? And another good thing is APM also provides a mechanism to configure alerts, right? Using historical performance as a baseline, you can configure alerts to notify a dedicated team or a personnel when performance metric deviate too much from your expectations or norm, right? For example, a recurring latency in a service or a high number of error rates in calling a node API, something like that, right? So in a way, APM or APM tools give you an instant feedback regarding system failures so that you can fix them and improve the performance. Okay, so now coming to the point, with an APM, now you make your process proactive at any given moment. You know the health and performance of your application, right? And as mentioned earlier, you actually open the black box, what was already there, and for any given transaction it will give you a complete visibility of your inner working of a system and reveal where the problem is located, which code, which method or backend is responsible for processing the delays or errors, and which is exactly the information you need to fix the issues or the problems in your application, right? Tracking and monitoring performance of individual requests is a critical too. So if you take an e-commerce application, which is, let's say, again, microservice based architecture, so the login service and the checkout service are also important, and rather than, I mean, individual monitoring and performance of services are also important rather than overall application monitoring, right? So another thing is that you can get to calculate different metrics like average response time, error rates, and also these things are important to capture to improve performance of an application. And the best thing is you get to create a robust alerting system when performance metrics are going down, such as if the instance is down, or if a service is down, or if you see that a particular, let's say, a Java service is taking too much time, and you can basically set an alert on that. So that's what APM. That's how your current system with an APM will be. So I mean, there are basic features that APM should have, like essential features. So I'll and these features are basically broadly covered in SigNoz already. So I'm just giving you a gist of, if you look to any APM tool, these are the essential features you should look for. So something like automatic discovery and mapping of application and its infrastructure components, right? Because your infrastructure these days are completely distributed, so you definitely need to keep an eye on what is going on back and forth in entire flow of an application, right? Not just code, not just network layer, not just DB layer, everything, right? So basically it should be able to give you the real-time awareness in a dynamic environment, and of course end-to-end observability of applications, a complete HTTP or HTTPS transactional behavior to understand or effect of business outcomes or user experiences, and root cause analysis of an application performance problem, which is faster, which is slower, and of course it should be able to help you in incidents resolution based on alerting system and all stuff. And again, you can do integrations and automation on top of your existing APM tools, and so that you can leverage more features as per your business needs, right? And then again, API monitoring and application performance, even if you are calling a third-party API, you could actually monitor that as well. So application architecture to gain insight into how your application changes, impact performance, user performance, and all stuff, right? So these are the basic features at least an APM tool should have. End user experience monitoring, so that it helps you understand how changes to applications affect end user as well, right? So now coming back to SigNoz again. So why do we use SigNoz? Why do we need it? Right? Again, I mean, it's an open source APM and observability tool built on top of different open source stack. And being a developer, it's kind of annoying to rely on closed source SaaS vendors for every small features, right? And again, closed source vendors are often surprise you with a huge month-end bills without transparency, right? It's very even hard to keep the transparency. So again, and then SigNoz discovers and monitors dynamic microservice workload running inside containers on Kubernetes, and see how they are performing, how they are communicating with each other, and immediately detect poorly performing microservices, right? And it supports a cloud native ecosystem. So what else do you need, right? And it also captures real-time transactions across different tiers, right? And in fact down to the code level, right? And it uses open telemetry for the observability, and you can set alerts on metric depending on your performance expectations, and you can find the root cause of problem by going to the exact traces which are causing the problems. Another thing is SigNoz really gives an amazing flame graph of individual request stress. So you can drill down on those details, and you can also check out what is the error rate of the particular and how many times this particular service or the code is failing. And again, the in the demanding business use case, companies that have privacy and security concerns about having customer data going to third data party services can use SigNoz as a self-hosted tool, and can be finally compared with the tools like Datadog and Neuralink. And being an open source tool also gives you a complete control of your configuration, sampling, and uptimes. You can also build modules on top of SigNoz to extend business specific needs. And SigNoz is highly configurable, whether it's a custom dashboard or setting up your alert notifications. Let's take a very quick bird's eye view overview of SigNoz architecture. I'm not going to tell you in very detail how exactly behind the scene it works, but if you see, this is how the SigNoz architecture looks like, and the components that you have seen in the dotted and the dashed rectangle bracket, that already comes with the SigNoz installation, right? So SigNoz collects data using OpenTelemetry, which is again an open source observability solution. Therefore, SigNoz supports all the framework and the languages supported by OpenTelemetry. You can find, complete guide on their documentation as well. And again, SigNoz aggregates all the data, and then that being used on dashboard to see all the metrics and traces related to your application. SigNoz basically includes this modules: OpenTelemetry collector, which collects the telemetry data of your services and application. ClickHouse, previously it was based on Apache Kafka, which is now being replaced with ClickHouse, which is an again open source high performance OLAP database management system. Query service for interface between front end and ClickHouse, built on top of Go, and front end for user interface, which is built on React and TypeScript. So I'm going to show you a quick dashboard or a UI of how SigNoz looks like, right? I'm not going to show you the demo of how exactly you can configure it. Probably we can create another video and then, or how to do a proper installation setup and all. So this is like an overall section. It provides you access to all the functionality you have to perform a specific activity. So number of applications, app specific details like application metrics, external calls, third-party calls, database calls. And a dashboard is again, this is like a section, and then here we go with the dashboard, and the dashboard is set of more graphs. In dashboard section you can create, update, delete dashboards, customize as per your need, right? And if you see, this is another example of a dashboard where the CPU load and containing two graphs and load average and total CPU time is shown, right? Okay, so now you can also, once you drill down into the a dashboard or trace details, you can actually perform operations on graph as well. You can hover over the graph to see actual values and specific point in time. Your graph shows application related metrics, so you can actually click on the points and then see the traces. So for example, you see here, right, if a graph shows an application related metrics, you can click on points and then view which traces are there, and all those latency categories, P99, P55, you can see all those things. Okay, so another good feature that I like about SigNoz is in the traces sections, you can actually visualize and aggregate metrics from traces. So SigNoz allows you to see aggregates of aggregates of your filtered traces, right? So for example, you can perform certain operations on it, like calculating values like count, rate per second, entire sum, average, max, 50th percentile, 99th percentile, and all those things, right? And another thing is you can also filter out it by all those values, and again the filter spans are actually attached with attributes and advancing filters as well.